The Existential Crisis Hotline. The Existential Crisis Hotline. The Existential Crisis Hotline. The Existential Crisis Hotline. The Existential Crisis Hotline.
Let me turn on my sound and let me turn off my AC. Give me 1 second. I just wanted you to be able to hear the dogs barking in the background. So, this is my salt gun for shooting flies. Very handy. If you like salt everywhere. Just so you weren't wondering what the hell that was. All right, so I see Gaitan's in the chat. What's up, man? I have the final proof for spoon bending. I've been on a search. I know you did some. You proved it can be done, but I found the definitive proof. I gotta show you this. This is amazing. Like seriously, genuinely amazing. Let me, 4 minutes. Let me back it up a little bit, just to build the suspense a little bit, okay? Because you gotta hear the setup.
But our subconscious is where our belief system, our permanent memories, our emotions, our feelings all reside. It's the most powerful part of our mind. So when I turned the TV set on and I just continued to rub the spoon every once in a while, testing it to see if I could feel anything, it was after a few minutes I could feel that it started getting a little bit, it's hard to describe, it's kind of a waxy feeling. And when it started getting that feeling, it became soft, and as I teach this, and as I'll be doing in a couple of days, when I do this in groups of people, about 80% of the people wind up bending their spoon.
First of all, when you see this, whatever seminar this guy is selling, I'm signing up.
And
You are right now.
I can feel that this is actually starting to get that way. And I'll see if I can do this for the camera. And let's see if we can see it happen. Bend. Bend. Yeah, there it goes. I don't know if you can see the handle, but it's starting to go. Bend. I don't know if you can see that.
I can see it popping up.
Let's see. Look.
I can see it popping up.
Yeah, look.
Oh, wow.
It actually bent quite a bit.
I just saw my first spoon bending.
And don't worry, you'll be doing it in a day or two. And the cool thing about it, in fact, I like to do this. This is kind of, I always do an homage to the movie The Matrix. In The Matrix, he says, there is no spoon, it's all in your mind. Well, this is actually a spoon. I'll do this for the camera. And it continues to go. And I'm doing this just for the camera. I don't know if you can see it, but yeah, it's going. Yeah, it's actually pretty badly bent.
Yeah.
I mean, except, hold on a second.
Look,
Oh, wow.
it actually bent quite a bit.
I just saw my first spoon bending.
And don't
Did
worry,
you,
you'll be
though?
doing it in a day or two.
Did
the
you?
cool thing about it, in fact, I like to do this. This is kind of, I always do an homage to the movie The Matrix. In The Matrix, he says,
Did you see it? Did you see it? Let me do that again. Watch the spoon in his hand. Watch the spoon in his hand.
Oh, wow.
it actually bent quite a bit in a day or two.
Okay, watch right
The
here.
cool thing about it, in fact, I like to do this. This is kind of, I always do an homage to
Watch him right now.
The Matrix.
Do you see it?
He says there,
Do you see him bend it? With his hand? He does it right there.
this is kind of,
All right, right here. Ready?
homage to,
He's gonna do it
the
now.
Matrix. In the
He's
Matrix,
bending it.
There is no spoon, it's all in.
Did you guys see it? he's like putting his hand down here and he's like bending it down. Come on, man. He's giving a bad rap to spoon bending. One more time.
I always do an homage to the movie The Matrix. In The Matrix, he says, there is no spoon, it's all in your mind.
Did you guys see it? Sandro, yeah. I think he's just trying to seduce this woman. I think that's all that's happening right now. What do you watch here one more time?
I always do an homage to the movie The Matrix. In The Matrix, he says, there is...
Come on, dude. At least with that other woman we watched, like, she was showing you, like, I'm gonna bend it right now, and she wasn't trying to, like, do it all fake style. Alright, well, that was disappointing, but I thought it was pretty funny. Now I'm getting all these spoon bending tutorials popping up in my algorithm. Okay. So I know last night in the chat when we were talking about math, the chat was going crazy. Everybody was like, talk more about math. Math, do more math. So I'm like, I mean, what can I do? Do I really have a choice here? But actually, I think this video is pretty interesting. Just to give you an idea, we're not going to do a bunch of math today. Maybe we will. If you guys really, really want me to, we will. But this is a really cool, I saw this video like maybe a few years ago about the overview of math, just to show you like how wide the field is. It's pretty crazy. All right, so here we go.
The mathematics we learn in school doesn't quite do the field of mathematics justice. We only get a glimpse at one corner of it, but mathematics as a whole is a huge and wonderfully diverse subject. My aim with this video is to show you all of that amazing stuff. We'll start back at the very beginning. The origin of mathematics lies in counting. In fact, counting is not just a human trait. Other animals are able to count as well. And evidence for human counting goes back to prehistoric times, with check marks made in bones. There were several innovations over the years, with the Egyptians having the first equation, the ancient Greeks making strides in many areas like geometry and numerology, and negative numbers were invented in China, and 0 as a number was first used in India. Then, in the golden age of Islam, Persian mathematicians made further strides and the first book on algebra was written. Then mathematics boomed in the Renaissance along with the sciences. Now there's a lot more to the history of mathematics than what I've just said, but I'm going to jump to the modern age and mathematics as we know it now.
Okay, so I want you to think back to school. I want you to think about what you learned in school and ask yourself, at what point in history did you stop knowing anything about math? Right? Like, for example, let's say you were talking about world history and you went to school and you learned, up through the Civil War. That'd be pretty obvious. You're like, I don't know anything that happened after the 1800s, right? You would know that, right? But when you study math in school, up through high school and even into college, what you'll see is you're not even really getting into anything that was done, especially in high school, after like the 1700s, really. But we'll see what he says. Maybe I might add some stuff to it. But same thing with chemistry, physics. Like in physics, even in high school, you barely scratch the surface on stuff that they discovered in like the 20s. Barely. Chemistry, same thing. You basically stop in like essentially the 1920s. Biology, you don't really get that far either, actually. It's kind of weird, right? Like around the time the school system was developed in like whatever the 1800s or so, that's pretty much when they like stopped adding more information to it. Kind of weird. I mean, except for history, I suppose, but even then it's still watered down.
Modern mathematics can broadly be broken down into two areas. Pure maths, the study of mathematics for its own sake, and applied maths, when you develop mathematics to help solve some real-world problem. But there's a lot of crossover. In fact, many times in history, someone's gone off into the mathematical wilderness, motivated purely by curiosity and kind of guided by a sense of aesthetics. And then they've created a whole bunch of new mathematics, which is nice and interesting, but it doesn't really do anything useful. But then, say, 100 years later, someone will be working on some problem at the cutting edge of...
He doesn't mean it's not useful, it just means when they created it, it wasn't useful.
physics or computer science, and they'll discover that this old theory in pure math is exactly what they need to solve their real-world problems.
That's weird, right?
Which is amazing, I think. And this kind of thing has happened so many times over the last few centuries. It's
You guys recognize that from the previous streams, Mandelbrot set?
interesting how often something so abstract ends up being really useful. But I should also mention that pure mathematics on its own is still a very valuable thing to do, because it can be fascinating and on its own can have a real beauty and elegance that almost becomes like art. Okay, enough of this highfalutin, let's get into it. Pure maths is made of several sections. The study of numbers starts with the natural numbers and what you can do with them with arithmetic operations. And then it looks at other kinds of numbers like integers, which contain negative numbers, rational numbers like fractions, real numbers, which include numbers like pi, which go off to infinite decimal points, and then complex numbers and a whole bunch of others. Some numbers have interesting properties like prime numbers or pi or the exponential. There are also properties of these number systems. For example, even though there's an infinite amount of both integers and real numbers, there are more real numbers than integers.
Think about that one. You think, but there's an infinite number of both, so how can there be more of one than the other? But mathematically speaking, it's true. The real numbers are like, you could think of them as like denser. For example, if you just take the number 1 and 2 and look at all the numbers that are in between 1 and 2 in the real numbers, which would include fractions, square roots, numbers like pi, they call them transcendental numbers. There's more numbers between 1 and 2 in that space than there are between 1 to infinity in the integers. And there's like a proof of it too. Maybe we'll do that later, we'll see.
So some infinities are bigger than others. The study of structures is where you start taking numbers and putting them into equations in the form of variables. Algebra contains the rules of how you then manipulate these equations. Here you'll also find vectors and matrices.
So algebra, you're probably at, I studied algebra in like 8th grade, but 8th and 9th grade high school, and then in America anyways. Matrices and vectors, you probably don't get into until probably like your junior year of high school in most cases. So like your 3rd year of high school.
Which are multi-dimensional numbers, and the rules of how they relate to each other are captured in linear algebra.
So like in college, I took an entire course on just linear algebra.
Number theory studies the features of everything in the last section on numbers, like the properties of prime numbers. Combinatorics looks at the properties of certain structures like trees, graphs, and other things that are made of discrete chunks that you can count. Group theory looks at objects that are related to each other in, well, groups.
So group theory, which is kind of under the concept of abstract algebra, we studied that as an entire 2-semester course in college. And combinatorics, you touch on that a little bit in high school, but you don't go into like trees and graph theory and stuff.
A familiar example is a Rubik's Cube, which is an example of a permutation group. And order theory investigates how to arrange objects following certain rules, like how something is a larger quantity than something else. The natural numbers are an example of an ordered set of objects, but anything with any two-way relationship can be ordered. Another part of pure mathematics looks at shapes and how they behave in spaces. The origin is in geometry, which includes Pythagoras, and is close to trigonometry, which I'm sure we're all familiar with from school.
So geometry is like 2nd year of high school usually, and then you get trig usually after that when you do algebra 2. Usually you do it with trig. Or some students, that's their 4th year of high school, they do what they call pre-calculus, which is a lot of trig and just other random stuff like linear algebra. But I took calculus in high school, and so we had to already know trig. But I think we covered trig in algebra 2 as well, so they kind of like throw it in here and there.
Also, there are fun things like fractal geometry, which are mathematical patterns which are scale invariant, which means
Fractal geometry, usually you wouldn't study at all in most cases, even as a mathematics major. I studied it a little bit because I had a professor who was kind of mentoring me a little bit on the side, and he gave me a textbook on chaos theory, which included fractals and basically chaos theory and fractals. And that's the only reason I studied some of that, and it was like outside of my normal courses.
you can zoom into them forever, and they always look kind of the same. Topology looks at different properties of spaces where you're allowed to continuously deform them but not tear or glue them. For example, a Mobius strip has only one surface and one edge, whatever you do to it. And coffee cups and
Didn't study topology at all in college as a math major.
donuts are the same thing,
Maybe there would have been a course I could have taken, but I didn't.
topologically speaking. Measure theory is a way to assign values to spaces or sets, tying together numbers and spaces.
Didn't study that.
And finally, differential geometry looks at the properties of shapes on curved surfaces. For example, triangles have got different angles on a curved surface. And brings us to the next section, which
Definitely did not study differential geometry, although that's like a precursor to understanding, like, gravity theory based on like Einstein and all that.
is changes. The study of changes contains calculus, which involves integrals and differentials, which looks at the area spanned out by functions or the behavior of gradients of functions.
Calculus studied in high school and also further in college. And it's actually a really interesting subject to me. They talk about, it's basically two different things. You've got the areas under a curve. So you see that green area under that curve. Like between 2 points on the curve, what's the area below it? You think that would be like a boring topic, but it's very useful. And then also the gradients, like how much does that curve change? Like how quickly does it change? Different things like about how it's changing and how the area underneath is changing. And that actually, those concepts lead to something called optimization, which is what was used to do a lot of the work with artificial intelligence leading up to like MLMs or LLMs and all that stuff.
And vector calculus looks at the same
And then differential equations, that was an entire course I took. Although we never really did vector calculus, but differential equations was a whole several courses.
thing but for vectors. Here we also find a bunch of other areas like dynamical systems, which looks at systems that evolve in time from one state to another, like fluid flows or things with feedback loops like ecosystems. And chaos theory, which studies dynamical systems that are very sensitive to initial conditions. Finally, complex analysis looks at the properties of functions with complex numbers.
I did take a course in complex analysis, also a course in real analysis. He never really referred to that specifically, but those are both separate courses.
This brings us to applied mathematics. At this point, it's probably worth mentioning that everything here is a lot more interrelated than I've drawn. In reality, this map should look more like a web tying together all the different subjects, but you can only do so much on a two-dimensional plane, so I've laid them out as best I can. Okay, we'll start with physics, which uses just about everything on the left-hand side to some degree. Mathematical and theoretical physics is a very close relationship with pure maths. Mathematics is also used in the other natural sciences, with mathematical chemistry and biomathematics, which look at loads of stuff from modelling molecules to evolutionary biology. Mathematics is also used extensively in engineering. Building things has taken a lot of maths since the Egyptians and Babylonian times. Very complex electrical systems like aeroplanes or the power grid use methods in dynamical systems called control theory. Numerical analysis is a mathematical tool commonly used in places where mathematics becomes too complex to solve completely. So instead you use lots of simple approximations and combine them all together to get a good approximate answers. For example, if you put a circle inside a square, throw darts at it, and then compare the number of darts in the circle and the square portions, you can approximate the value of pi. But in the real world, numerical analysis is done on huge computers. Game theory looks at what the best choices are given a set of rules and rational players, and it's used in economics when the players can be intelligent, but not always, and other areas like psychology and biology. Probability is the study of random events like coin tosses or dice or humans, and statistics is the...
So far, probability and really just probability is the only applied math course that I took in college so far. I never took statistics, but I did tutor it, so I basically took it also. But
study of...
Yeah, where's the Chinese professor guy?
Large collections of random processes, or the organization and analysis of data. This is obviously related to mathematical finance, where you want to model financial systems and get an edge to win all those fat stacks. Related to this is optimization, where you're trying to calculate the best choice amongst a set of many different options or constraints, which you normally visualize as trying to find the highest or lowest point of a function.
It's funny because this video is 9 years old, so he didn't mention AI within it. But to give you a kind of general idea, imagine the correct answer is at the very top of that little yellow mountain. So optimization, it's like you're trying to find a certain point. And so the way they develop these LLMs and train them, that's kind of the part of the process of how they do that, is using this optimization.
Optimization problems are second nature to us humans, and we do them all the time, trying to get the best value for money or trying to maximize our happiness in some way. Another area that's very deeply related to pure mathematics is computer science, and the rules of computer science were actually derived in pure maths and is another example of something that was worked out way before programmable computers were built. Machine learning, the creation of intelligent computer systems, uses many areas in mathematics like linear algebra, optimization, dynamical systems, and probability. And finally, the theory of cryptography is very important to computation and uses a lot of pure maths like combinatorics and number theory. So that covers the main sections of pure and applied mathematics. But I can't end without looking at the foundations of mathematics.
Oh boy.
This area tries to work out the properties of mathematics itself and asks what the basis of all the rules of mathematics is. Is there a complete set of fundamental rules, called axioms, which all of mathematics comes from? And can we prove that it's all consistent with itself? Mathematical logic, set theory, and category theory try to answer this, and a famous result in mathematical logic are Gödel's incompleteness theorems, which, for most people, means that mathematics does not have a complete and consistent set of axioms, which means that it's all kind of made up by us humans. Which is weird, seeing as mathematics explains so much stuff in the universe so well. Why would a thing made up by humans be able to do that? That is a deep mystery right there.
Just because it's incomplete doesn't mean that it's made up by humans necessarily, but...
We also have the theory of computation, which looks at different models of computing and how efficiently they can solve problems, and contains complexity theory, which looks at what is and isn't computable, and how much memory and time you would need, which, for most interesting problems, is an insane amount. So that is the map of mathematics. Now, the thing I've loved most about learning maths is that feeling you get where something that seemed so confusing finally clicks in your brain and everything makes sense, like an epiphany moment, kind of like seeing through the Matrix. In fact, some of my most satisfying intellectual moments have been understanding some part of mathematics and then feeling like I had a glimpse at the fundamental nature of the universe in all of its symmetrical wonder. It's great. I love it.
Interesting. I was thinking about looking at this information theory stuff, but I have something that's super interesting. Perhaps far more interesting. Well, anyways, it's just interesting to me. Have you guys ever heard of the Monty Hall problem? Okay, I'll give you some context first. It's not the full Monty, and it's not Monty Python. But this is really interesting. And I remember looking at this a while back, many years ago, like probably, must have been like more than 10 or 15 years ago. And Super fascinating. Okay, I think you guys will like this though. So the Monty Hall problem is a brain teaser in the form of a probability puzzle. Okay, so there was a TV show called Let's Make a Deal, and the guy's name was Monty Hall. And basically, let's see. Okay, so here's the thing. Suppose you're on a game show. You're given the choice of 3 doors, just like in this picture over on the right. Behind one door is a car. Behind the others are goats. So behind 2 doors are goats, and one door is a car. So here's how it works. You pick, let's say, door number 1. And what happens is the host, who knows what's behind all the doors, he opens one of the doors that has a goat. Okay? Which it could be either one of those, but he knows which one it is. And then before he opens your door, he says, do you want to stay with your choice? Like, let's say you pick number 1. He opens number 3, there's a goat there. He says, do you want to keep your choice, or do you want to open door number 2 instead? And you have to decide, do I stick with the choice I have, or do I open the second door? Okay, instead. So so I'll just tell you what it says here, like the explanation. But man, it's one of these things that sometimes it seems obvious, but then you start thinking about it and you're like, no, actually maybe it should be the other way. And then suddenly it makes sense. Yeah, it should definitely be the other way. And you think about it more and you're like, no, it should be the other one. Like, so what do you guys think? Should he switch doors or not switch doors? So the guy who sent it in, who I guess it was solved by Marilyn Voss Savant. It's kind of an ironic name. Is that an actual person? Okay, yeah, her name was not actually Savant. I'm like, that'd be kind of... Oh no, it says her parents were Joseph Mock and Marina Voss Savant. So this person's a savant? And also their last name is Savant? Is that where the word comes from? It doesn't say that. Oh, look, Fermat's last theorem. I was actually thinking about that too. Maybe we'll talk about that later. Okay, so Savant's response was that the contestant should switch the door to the other door. Okay. I'm not saying this is right, but this is just what they said. By standard assumptions, the switching strategy has a 2/3 probability of winning the car, while the strategy of keeping the initial choice has only a 1/3 probability. Let's think about that. Again, maybe, I don't know if everyone experiences this, but you have to think about it a little bit. To me, it's like such a not intuitive thing. So you have the 3 doors, you choose one, they open door 3, there's a goat. Before they open the door, what is the odds of you picking the correct one? 1 in 3, right? But I think according to what they're saying here, now, imagine you didn't pick either door already. So like, I mean, you did, but like now think of it like as a new choice. Okay, so now there's really just 2 doors. So you think it's 50-50, but it's actually 2/3. I thought it made sense, but it doesn't. Okay, let me keep going. When the player makes the first choice, there's a 2/3 chance that the car was behind one of the doors not chosen. Okay, that makes sense. Actually makes sense. This probability does not change after the host reveals a goat behind one of the unchosen doors. When the host provides information about the 2 unchosen doors, revealing that one of them does not have the car behind it, the 2/3 chance of the car being behind one of the unchosen doors rests on the unchosen and unrevealed door, as opposed to the 1/3 chance of the car being behind the door the contestant chose initially. Did that make sense, guys? I mean, it kind of makes sense. So initially, you have a 1/3 chance of choosing correctly. So the chance is 2/3. that you're choosing incorrectly. That makes sense to me so far. But this part doesn't. When the host provides information about the two unchosen doors, so now you know one of them has the goat, the 2/3 chance of the car being behind one of the unchosen doors rests on the unchosen and revealed door. Okay. I feel like I'm getting it, but I'm not sure. As opposed to the 1/3 chance of the car being behind the door the contestant initially chose. The given probabilities depend on specific assumptions about how the host and contestant choose their doors. An important insight is that, with these standard conditions, there is more information about doors 2 and 3 than was available at the beginning of the game, when door 1 was chosen by the player. The host's action adds value to the door not eliminated, but not to the one chosen by the contestant originally. Another insight is that switching doors is a different action from choosing between the two remaining doors at random, as the former action uses the previous information and the latter does not. Sure. Other possible behaviors of the host than the one described can reveal different additional information around it all, leading to different probabilities. Okay. Suppose there are 1,000,000 doors and you pick door number 1. Then the host, who knows what's behind the doors and will always avoid the one with the prize, opens them all except door number 77777. You'd switch to that door pretty fast, wouldn't you? Yeah. Okay, so maybe that's part of it. Probability is transferable? I don't know. It's like... But I think that's kind of the insight there. It kind of makes sense to me. Like, okay, so... the doors are closed. You choose one. They're definitely not going to open the one with the car. That's obvious. I still don't see how that tells you anything. What the hell? The problem for me is when I'm thinking about it, I'm like, well, but you're not doing this more than once. Like maybe over time it increases your odds. But isn't it still now just 50-50? How does it actually change the odds? Like intuitively it makes sense to me. Perhaps if you did this repeatedly. I could see a potential possibility that that strategy could work over time. You'd more often choose the correct one by switching, maybe. But if you're just doing it one time, it doesn't make sense to me. That's the thing about probability. It's like you're only doing it once, though. You're not doing it a whole bunch. Many readers of Savant's column refused to believe switching is beneficial and rejected her explanation. After the problem appeared in Parade, approximately 10,000 readers, including nearly 1,000 with PhDs, wrote to the magazine, most of them calling Savant wrong. Even when given explanations, simulations, and formal mathematical proofs, many people still did not accept the switching as the best strategy. Paul Erdős, one of the most prolific mathematicians in history, remained unconvinced until he was shown a computer simulation demonstrating Savant's predicted results. So this dude was like, I read a biography of this guy. This dude was... he was wacky, man. Super math genius. And he was like, no. Maybe that's my problem. I can't understand because I'm too smart. That's definitely it. The problem is a paradox of the veridical type, because the solution is so counterintuitive, it can seem absurd, but is nevertheless demonstrably true. Monty Hall problem is mathematically related closely to the earlier Three Prisoners dilemma and to the much older Bertrand's box paradox. Maybe we can look at those. Okay, let's look at this. Simple solutions, the three possible arrangements. So in one case, you've got So they're in rows. You've got goat, goat, car. Goat, car, goat, and car, goat, goat. Goat, goat, car. Okay, in Go Go Car, if you choose, you're choosing always number one, I guess, in this scenario. If you choose one, they're going to reveal number two, and then by switching, you would win. In the second column or the second row, you have a goat. They're going to open the third door. You're going to choose it, and you're going to win. If you switch. So I'm just talking about only if you switch. And the first one, you chose the car, and then by switching, you lose. Huh. I feel like that kind of proves it, doesn't it? So you either have it's either goat, goat, car. It's either goat, car, goat, or car, goat, goat. Wow, that actually makes sense. I never saw it put that simply before. Does that make sense to you guys? It kind of actually makes sense to me because if you look at the three scenarios, then it would apply even if you switched it up. You chose door 2 every time or chose door 3. But if you chose door 1 in the three different possible scenarios, the odds of you choosing the car the first time is 1 in 3. Oh, this makes sense. I don't know why it's so hard for people to understand that. That just seems obvious. I feel like it can't be that simple. Yeah, okay, it makes sense to you too. I'm like, how could it be that simple though that like nobody believed it? I don't understand. I mean, when you're just looking at it like this, the explanation, I was kind of confusing maybe the way it's written, but when you look at it like this, I feel like it shouldn't be obvious. I'm like, there's got to be a catch here. A player who stays with the initial choice wins in only 1 out of 3 of these equally likely possibilities, while a player who switches wins in 2 out of 3. Makes sense. An intuitive explanation is that if the contestant initially picks a goat, the contestant will win the car. Okay, that's another way of looking at it. You're more likely to pick the goat first. I think that even makes it more intuitively obvious. What are you more likely to pick the first choice, a car or a goat? You're more likely to pick a goat. So therefore, it's still such a mind fuck, dude. Such a mind fuck. Yeah, it's so weird because it's like probability. It's like the reason why it's weird to me is like because in reality, it's like a static thing. There's actually a goat, a car, and a goat. So when you choose it, it's not like the odds are in the air still of what you chose. You either chose it or you didn't. But again, it's so weird, man. It's so weird. Because the only way, like even though this explanation makes complete sense to me, it still doesn't. And this is what I was trying to say earlier, because I've thought about all this before, where it's like, okay, yeah, I know that makes sense. But at the same time, it only makes sense if you play it multiple times. That's the part I have trouble wrapping my mind around, which is, yeah, if you did this 3 times and you chose that strategy, you'd win more often. But there's a chance you're just going to choose the card in the first place. And whatever the scenario is doesn't depend on the likelihood of any other scenarios happening. It's such a weird thing about probability. Okay, I want to read this. Did I say this part? Yeah. An intuitive explanation is that if the contestant initially picks a goat 2 of 3 doors, the contestant will win the car by switching because the other goat can no longer be picked. The host had to reveal its location. Whereas if the contestant initially picks the car, 1 of 3 doors, the contestant will not win. Okay. Using the switching strategy, winning or losing thus only depends on whether the contestant has initially chosen a goat, 2/3 probability, or the car, 1/3 probability. The fact that the host subsequently reveals a goat in one of the unchosen doors changes nothing about the initial probability. So, god damn, dude. Do you guys have any cognitive dissonance about this, or is it just me? Like, I get the explanation. It makes perfect sense to me. But, at the same time, you're only going to do it once. That's the part that I'm like, you're only going to do it once. So, I don't see how anything really fundamentally changes. How a strategy matters in this case. Like, let's say this game was ever only going to be played one time ever in history. Only one time. Then what does probability and odds have anything to do with it? What if the door the host reveals is the one you chose if you picked a goat? I don't think that's how it works. I think they open one of the other ones. Or you just mean like, what if you switched it to that scenario? Like, what would happen? I don't know. Most people conclude that switching does not matter because there will be a 50% chance of finding the car behind either of the 2 unopened doors. This would be true if the host selected a door to open at random, but this is not the case. The host opened door depends on the player's initial choice. Does it? Oh, I see why. Because they don't know which door you're going to choose. I keep going back to you're always opening door number 1. You could open any of the doors. It's still weird because no matter what door you choose, he's going to open a door with a goat. There's not 2 cars. Before the host opens a door, there's a 1/3 probability that the car is behind each door. If the car is behind door 1, the host can open either door 2 or 3. So the probability that the car is behind door 1 and the host opens door 3 is 1/3 times 1/2 equals 1/6. So if the car is behind door 1, the host can open either 2 or 3. So the probability that the car is behind door 1 and the host opens 3 is 1/6. If the car is behind door 2, with the player having picked door 1, the host must open door 3, such that the probability that the car is behind door 2 and the host opens door 3 is 1/3. These are the only cases where the host opens door 3. So if the player has picked door 1 and the host opens door 3, the car is twice as likely to be behind door 2 as door 1. What? I gotta go back. Okay. I need like a whiteboard or something. If the car is behind door 1, the host can open either door 2 or 3. Okay. So the probability so if the car is behind door 1, the probability would have been 1/3 that it was right there. If you chose that one, because then that's why host would either open 2 or 3. He has a 50-50 chance of opening either 2 or 3. That's the 1/2, I suppose. because the goat would either be in one of the other ones. So that's where you get the 1/6. Okay, I see why they're saying that. Because if you chose if it was behind car or door number 1 and you chose it, then it's 50-50 which one they're going to open next. But if you chose door 1 and the car was behind door 2, it's no longer 50-50 which one they're going to open. They have to open door 3. They have to open door 3. It's 100%. So your odds are 1/3 on that one. Wow. That's still so weird. What if the door... Oh, you already read that. I thought that was a new comment. That's still so weird. The key is that if the car is behind door 2, the host must open door 3. But if the car is behind door 1, the host can open either door. Yeah, I get that. I still don't see how it fundamentally... That's what's so weird about it. I get it. I get the probability. But it still intuitively feels like it doesn't really matter. It's so strange. Makes you wonder if the way we process information isn't based on probability. Another way to understand the solution is to consider together the 2 doors initially unchosen. As Cecil Adams puts it, Monty is saying, in effect, you can keep your 1 door or you can have the other 2 doors. You can keep your 1 door or you can have the other 2. Again, makes sense, but it doesn't feel right. It's a problem with feelings. The 2/3 chance of finding the car has not been changed by the opening of one of these doors because Monty, knowing the location of the car, is certain to reveal a goat. The player's choice after the host opens a door is no different than if the host offered the player the option to switch from the original chosen door to the set of both remaining doors. The switch in this case clearly gives the player a 2/3 probability. Okay, I feel like that kind of makes sense, actually. Think about it like this. Yeah, okay. I think this is what this is trying to say. You choose 1 door. Now imagine that they don't even open the other 2. You just choose your first one. And they're like, all right, you can stay with that one, or you can choose the other 2. And if you choose the other 2, I'm going to open up one with the goat, and you're going to get whatever in the other one. I'm going to open up one that definitely has a goat, and you're going to keep the one that I don't open. That's another way of thinking about it. Wow. That totally makes sense to me. Because the odds of you choosing it right in the first place is 1/3. But then they're saying, now we're going to group the one you chose and the other 2 and let you choose again. Do you want to choose one that has 2? So there's 2 possibilities of the car being there, or the 1. Now you would think, well, if you choose the other 2 and then randomly they open them and you get whatever's behind it, that doesn't make sense. But if they're like, no, we're definitely going to throw out the goat in the other one. There could be 2 goats. That's a possibility. But there's only a 1/3 chance that you chose the car in the first place. There's a 2/3 chance. Is it 2/3? 2/3 chance that the car isn't in the one you chose. That's a better way of thinking about it. So the car, so you choose initially, Whatever you choose, there's a 1/3 chance you chose correctly and 2/3 chance you chose wrong. So if they say now you can choose the other section that has a 2/3 chance more likely of the car being there, and we're definitely going to throw out one of the goats, it just makes sense. It would be more likely to win. How does just asking another question change the probability, though? That's the thing. What I'm realizing is it doesn't change the probability. It doesn't change it. Let me see if I can do a whiteboard. Is that like a possibility? Oh, yeah, okay. Like that was going to get me what I wanted. Whiteboard online? Can I just like draw on something? Hey, here we go. I can make squares. All right. Wow, that actually works pretty well. Okay, I'm going to figure this out, guys. Here we go. You know, I can do this. We got door 1. Can I copy things? Copy. Paste. No, that doesn't work. Can I duplicate them? Apparently not. All right, I'll just draw another one. Door number 2. Door number 3. Pretend like they're all the same size. So we got 1, 2, 3. If you know a car is only behind one of them, what are the odds you choose it correctly? If I think it's here, if I choose this one, it's 1 in 3 that I'm correct. What are the odds that the car is over here? For it to be in here is 1/3. The odds of it being over here is 2/3. So if they just started the thing by saying, do you want to choose and see if the car's in here, or do you want to guess if the car's in here? That's the question, actually. It's more likely the car is in this section. Or whatever second grouping. Like if you choose 3, it'd be 1 and 3. Or if you choose 3, it'd be 1 and 2. It's more likely to be in the set of 2. Because since they do this whole process of opening the door and all that stuff after you make your choice, it's like, just imagine they never opened the doors and they just said, look, if you choose the second one, then we'll eliminate one of the goats. That's it. Right? So if there's a goat, if they're both goats, then yeah, you lost because you switched. But it was less likely you chose it right in the first place. That's pretty much it. It's actually not that complex. So it's just a matter of, if you're just thinking about it in terms of odds. All right, Sandro gets it, so I think we're good. Because if we both get it, that means something. As Keith Devlin says, by opening this door, Monty is saying to the contestant, there are 2 doors you did not choose. And the probability that the prize is behind one of them is 2/3. I'll help you by using my knowledge of where the prize is to open one of those 2 doors to show you that it does not hide the prize. Yeah, none of that really matters, is what I'm realizing. No, I don't. I think really this just explains it. Now, if you want the goat, then I think you should stick with your original choice. See, I don't even think you need all that intuition, honestly. When presented with the Monty Hall problem, an overwhelming majority of people assume that each door has an equal probability and conclude that switching does not matter. Out of 228 subjects, only 13% chose to switch. No other statistical puzzle comes so close to fooling all the people all the time. And even Nobel physicists systematically give the wrong answer, and that they insist on it. They're ready to berate in print those who propose the right answer. Pigeons, repeatedly exposed to the problem, rapidly learn to always switch. What? How do they do that? Pigeons, Monty Hall. What? Are birds smarter than mathematicians? Pigeons perform optimally on a version of the Monty Hall dilemma. How did they do it? A series of experiments investigated whether pigeons, like most humans, would fail to maximize their expected winnings in a version of the Monty Hall dilemma. Birds completed multiple trials of a standard Monty Hall dilemma with the 3 response keys in an operant chamber serving as the 3 doors and access to mixed grain as the prize. Across experiments, the probability of gaining reinforcement for switching and staying was manipulated, and birds adjusted their probability of switching and staying to approximate the optimal strategy. Replication of the procedure with human participants showed that humans failed to adopt optimal strategies even with extensive training. What? Animals are frequently presented with choices where the outcomes associated with each option are ambiguous and probabilistically determined. A classic example is the decision of where to forage for food. A location has the signs of being food-rich might recently have been picked clean, and a location that appears to be food-poor might contain an unseen cache. Thus, an animal cannot be absolutely certain of the outcome of its choice. A low probability or bad choice might yield a favorable outcome, and a high probability or good choice might produce disastrous results. However, even if the chooser cannot be absolutely certain, many of the choices are associated with a particular probability of success. Okay, optimal foraging. How did they actually do it, though? Where'd it go? A simple probability learning experiment reinforcement is available by responding on one of 2 alternatives, each of which is associated with a specific likelihood. Okay, here we go. 6 silver king pigeons were obtained from a local breeder. Okay, all right. 3 BRS/LVE operant chambers were used. The front wall of each chamber contained 3 pecking keys and a feeder through which birds would gain access to mixed grain. Each chamber was interfaced with a personal computer that controlled all experiential. Okay. All birds were pre-trained in sessions consisting successively of habituation, magazine training, and auto-shaping. Yeah, if you switch, yeah, that's a good point. You're like an idiot if you switched and you got it wrong. Okay, I'm trying to figure out how they actually did it. At the beginning of a trial, the computer randomly selected one of the 3 keys as the prize location. Then all 3 keys were illuminated with white light. After the bird pecked at any one of the lit keys, all 3 keys were darkened for 1 second. During the 1 second delay, the computer pseudo-randomly selected one of the 3 keys to deactivate for the remainder of the trial, with the constraint that the deactivated key could not be the one selected as the prize location for that trial, nor could it be the one that the bird had pecked. Okay, so that's how they did it. Okay, so you have 3 keys, they light up, it pecks one, they turn off, Then it lights back up, but one of them is removed, one of the ones they didn't choose, which would be like opening the door and showing there's a goat there, essentially. So now they have to either peck the same one again or choose the other one. The two remaining keys, the key that the bird had just pecked and one other key, were then illuminated with green light. If a bird then pecked the key that corresponded to the prize location, it was given approximately 3 seconds to access to mixed grain. Following a 5-second ITI, moved along to the next trial. If a bird's second response did not correspond, no reinforcement was provided, and the procedure simply moved to the ITI in the next trial. In intertrial interval. For each trial, the result of interest was whether the bird pecked the same key on its second choice as it did on its first choice. If it did, the bird was said to have stayed. If the bird pecked a different key than it did, it was said to have switched. On average, staying would lead to food delivery 1/3 of the time, and switching would lead to reinforcement 2/3 of the time. Mean percent of responses. Day 1. Wow. So I wonder, did they say how many times they did it? Yeah, so initially they stayed more often than they switched, not 50-50. They were more likely to peck it again initially. Did it say individual trials? 10 trials on the initial day gradually increased to 100 over the first 5 days. Okay, so they did it a bunch. Like, they didn't just like do it once each day, but still, that's interesting. So by day 30, they pretty much were all switching. Like 90-something% of the time, did it say? 96.33%. Wow. Figure 2 shows the proportion of reinforced trials on the initial and final days of the experiment. On day 1, pigeons' choices were reinforced on 47%. On day 30, pigeons were reinforced on 63%. I don't really understand that. I don't understand this reinforcement. Reinforcers earned. Does reinforce just means they actually got the feed? I think it explained it earlier. Yeah, okay. If a bird's second response did not correspond to the prize location, no reinforcement was provided. Okay, so reinforcers earned. What was the percentage? Oh, interesting. Okay. So they're saying on day 1, when they were mostly choosing to stay, they got it right 47% of the time, so less than half. But on day 30, when they used the switching strategy predominantly, they were reinforced 63% of the time, meaning they got the reward 63% of the time. So, which is also another measurement that they're doing inadvertently, right? So they're actually testing the theory itself, which is basically 2/3. There was 6 birds in the experiment. What is the LL? Possible response paths. Okay, like left, 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 center, left, right. Okay. Like the choices they can make. They could do left, 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 center, left, right. It's all the different combinations. Okay, well, that's not very interesting. In an iterated Monty Hall dilemma, such as the one in Experiment 1, the optimal strategy is to switch on every trial. Doing so will result in wins on 2/3 of all trials. While this necessarily means that the remaining 1/3 of trials will be losses, no other strategy can match or exceed it. Most strategies result in reinforcement of 50%, and some can yield considerably worse outcomes. I guess you could have other strategies of like, if I choose one and then one isn't highlighted, I always switch. But if I choose 2 and 2 isn't highlighted again, or I don't know, like if I choose 1 and then the middle one goes out, then I always choose the third one. But if I choose 1 and the third one goes out, I stay. Like that would be like a weird strategy that you're just making it up. But anyways, if you come up with other strategies, I said it's either 50% or less. All 6 pigeons learn to switch consistently, and by doing so they earn close to the maximum possible payoff. Considering that switching produces a higher rate of reinforcement than staying, the procedure appears to be one that naturally shapes pigeons to switch. So it's not so much that they're smart, they're just like machines. Maybe they are smart. While choices to stay were initially more abundant, choices to switch were twice as likely to be reinforced. That's the thing. It's a matter of what's being reinforced. That's crazy, actually. It's just training. Huh. Makes you wonder if they did it with humans, with adults versus like really young children, if there would be a difference between the adults and the children. Because they're just like, it's like a training thing. Whereas like with humans, we think about stuff, so our thinking would get in the way of it. Okay, Sandra said, okay, but it also hit one of the keys and didn't get something. So then was trying the other key, so is that really a valid comparison? But that's what maybe I'm misunderstanding your comment, but initially that's what they would just stay on it, usually, and hit it again. I'm not really sure I'm not sure. Can you clarify maybe? Simple and parsimonious, what is it? Experiment 2. Okay. Was there 2 experiments? Or do they just mean, what do they mean by experiments? Experiment 1. Okay, so that was 1 experiment for 30 days. Okay, so there's a second experiment? Okay. A simple and parsimonious interpretation of experiment 1 might be that the pigeons learned to switch rather than stay by trying each possibility and then consistently choosing the one that yielded the most frequent payoffs. If this interpretation is true, then it should be possible to change the likelihood of switching by manipulating the relative likelihoods of reinforcement associated with switching and staying. By the above interpretation, birds in experiment 1 chose to switch so assuming that this is the case, they chose to switch simply because switching had maximized the probability of gaining reinforcement on previous trials. However, consider a reversed version in which the likelihood of reinforcement is greater if a player stays with their initial choice. This version is interesting because it is conceivable but highly unnatural and could only occur if the location of the prize is determined after the player's initial guess. If pigeons learned whether to stay or switch based on experience with the problem, they ought to be capable of learning to stay just as easily as they learn to switch. So the current interpretation then would predict that pigeons would learn to stay just as they learn to switch. Okay. So in this one, the prize location could only be determined after the pigeon made its initial choice. Specifically, the prize location was determined to be the key that a pigeon had just pecked with a probability of 2/3. The prize location was linked to the 2 keys that had not been pecked with a probability of 1/6. One of the keys was then deactivated. Again, the critical result for each trial was whether a pigeon stayed or switched. Note that in experiment 2, the probabilities of reinforcement associated with staying and switching are the converse of experiment 1. Staying would lead to reinforcement 2/3 of the time, rather than 1/3, and switching would lead to reinforcement 1/3 of the time. Figure 3 shows the probability of staying and switching on the first day of the experiment and on the 15th and final day of the experiment. So initially, they were staying like before. And then you get the same result, but in reverse. How do they interpret that? In experiment 2, birds learned to stay with their initial choices. Note that they learned to do the opposite of what pigeons did in experiment 1, but they presumably did so for the same reason. In both cases, the adopted response strategy was the one that maximized the potential to earn reinforcement. What was the okay? I mean, what other possible interpretation is there, though? It's interesting that birds apparently learned to stay with their first choice in experiment 2 more quickly than birds learned to switch in experiment 1. On the surface, this finding has potential to bridge the gap between pigeons' optimal performance and humans' suboptimal performance. That is, humans have shown a tendency to stay that is extremely difficult to overcome. Pigeons are apparently not quite as rigid, but they did learn to stay more quickly than they learned to switch. However, one should be hesitant to make a claim that staying is easier for pigeons to learn for 2 reasons. First, pigeons began both experiments with a slight tendency to stay, and thus had further to go in experiment 1 to reach a stable optimal strategy of always switching. So they already were staying in the first place. So if it got reinforced to stay, it may be easier to stay than it would be in the other experiment to switch. In experiment 2, the same initial response distribution was quite close to the optimal strategy of always staying, which would naturally produce a shorter acquisition time given the same learning rate. So since they were already doing the optimal strategy, as it's reinforced, it would be easier to stay with that strategy. Second, pigeons likely had the slight tendency to stay in the first place because of the relative distances to the keys required for stay and switch responses. In the case of a stay response, regardless of which key was initially pecked, a pigeon was still likely physically closest to that same key, which makes sense too. The motivation for experiment 2 was to test the interpretation that pigeons in experiment 1 had learned to switch based on their history of reinforcement during previous trials. This interpretation was supported, as birds in experiment 2 adopted a different strategy appropriate to the different probabilities of reinforcement in effect. While this interpretation seems quite intuitive, it is not the only possibility. That's what I was wondering. What are the other ones? Consider that the procedure used in experiment 2 was highly non-natural, and that staying can only be the optimal strategy if the location of the reinforcer is determined after a pigeon has made its initial response. This is quite a bit different from the natural world, in which locations of physical things such as items of food do not suddenly change as a result of unrelated behaviors at separate locations. The fact that the correct solution to the original MHD is to switch is dependent on this constraint. Thus, if this real-world constraint were a heavy factor in Pigeon's performance, it is entirely possible that pigeons might have responded during Experiment 2 just as they did in Experiment 1 by consistently switching. If this had happened, it would have implied that the pigeon's optimal behavior in Experiment 1 was based on something other than or in addition to reinforcement history. Okay. I don't really understand the point, though. I mean, I get what they're saying, but... Where'd it go? Consider that the procedure used in Experiment 2 was highly non-natural. Because they are determining the likelihood of it being in one place or another after they've made their choice. What then accounts for the difference between the approximately optimal performance of pigeons and the suboptimal performance of humans in parallel situations? Are they saying they ran the experiments the same number of times with people and pigeons still did better? I don't know. Maybe there's some history of this. I'll have to look into that. One possibility is the Experiment 1 was an iterated MHD involving repeated trials. The MHD is traditionally proposed as a single choice. Yeah, see, I think that was your question, right? The difference is important because of the result just discussed, that pigeons apparently learn to switch based on feedback. Yeah. When the MHD is expressed as a single choice, there is no opportunity to learn. Thus, it may seem possible, even likely, that human participants who fail to switch on an isolated MHD trial might nevertheless settle into an optimal switching strategy if given the opportunity to learn. Surprisingly, this is not what happens. Granberg and Brown, 1995, gave human participants repeated trials of the MHD, finding that while their participants did become more likely to switch, they did not do so consistently and did not approach the optimal strategy of switching on 100% of trials. Instead, they settled into a pattern where they distributed about half of their responses, each to staying and switching. Even when an incentive was provided for switching, only a small percentage of their participants reached the optimal solution on switching every trial. Huh. Honestly, the only thing I can say is it's probably because people think. Like, the pigeons are not thinking about it. It's just a physical reinforcement. Huh. So interesting. The results from the pigeons in Experiment 1 and 2 are interesting, given that most humans fail spectacularly when faced with the MHD. While it may be that pigeons are simply better suited to the problem, there are some other plausible explanations for the differences. First, investigations of the MHD using human participants usually utilize some sort of anecdote or story, which may or may not involve game shows, doors, and goats. In contrast, the pigeons saw merely illuminated response keys and were given the opportunity to learn via trial and error. This difference may be an important one, given that Burns and Wythe showed that MHD-style problems having the same underlying mathematical structure but a different cover story were not equally likely to be solved. Kind of reminds me of the red-blue button thing. Kind of makes you wonder if that was just like a big experiment that was being run on social media. The red button, blue button thing. Where people were asked, okay, there's two buttons, a red button and a blue button. If you press the red button, you survive no matter what. If you press the blue button, you only survive if more than 50% of people push the blue button. And if 50% of people push the blue button, everyone survives, even the people who pushed red. And it was like for like a day or two, like the entire internet, it seemed like, or at least on X, was just like going crazy over this thing. And everyone had the strategies, and it was so interesting. Because like on the one hand, it was like, okay, if everybody just pushed the red button, everyone survives. Like, and then people would reformulate it into other ones to be like, it's so obvious you should press the red button. Like, okay, let's see you saw two buttons. One says, you press this button, nothing happens. You press this button, you die. Unless 50% of people press that button. They try to like come up with all these different formulations to say like, why would anybody... Okay, here's another one. You can stand over here, or you can go underneath this thing that'll crush you unless 50% or more people go underneath it. Would you walk underneath it? Like all these different ways of like thinking about it. And but it's like at the end of it, I always came back to the point of, well, you only need 50% of people to get under there or push the blue button. And some people aren't. So it makes sense to push it even though I don't want to die, but some people are. And I don't want to, it's like this. And then the people on the red button pushing side were like, oh, you're just pressing the blue button because you want to virtue signal that you're a good person and everything. And it's like, yeah, I get that perception. But at the same time, if people press it, they're going to die. Why would they press it? I don't know why they would press it. That's why I got to press it. And then it's like, now I'm one of those people that don't know why they pressed it, but I pressed it because I don't know if other people would press it or not. It's like totally a mind fuck, like completely. Worse than the Monty Hall problem. And the funny thing is, apparently they've done this, and actually we could look into that too, but just the ones I saw on X, like these Twitter polls, it would always be like 64% blue. Crazy. And apparently it's been done many times. Okay, I'm going to finish this up. Furthermore, people can be made to overestimate the probability of a random event, such as winning a lottery, if the random event includes factors from skill situations, such as choice or competition. While mathematically, a participant's initial selection does not affect the likelihood of winning in the MHD, it may be the case that the participant believes that it does. If so, then the game show anecdote may contribute to the same illusion of control shown by Langer and result in a suboptimal tendency to stay. Kind of like what Sandra was saying about you don't want to look like an idiot. But it's like another way of looking at that. My choice matters. My vote mattered. Pigeons, therefore, may have performed well because they're not subjected to the cover story. Dude, that's like a whole psychological thing right there, isn't it? Like, if you can give the right cover story, you can get people to do stuff that's suboptimal. Optimus, best. You can do things that aren't best just by giving the right cover story. Kind of like with that red button, blue button thing. You can actually get somebody to choose to possibly kill themselves by giving it a cover story. Ideally, everyone would just be like, I want to live. I'm pressing red. If this were the case, humans presented with a stripped-down version parallel to the method used in Experience 1 and 2 might be more likely. I wonder if they've done that. Well, I guess they did. Here we go. Oh, so are we in Experiment 3? Okay. I like this. I think science is so interesting because they're like, yeah, but what if this was the explanation? Well, then this would probably happen. So let's test that and see. It's kind of fun. Man, it's so interesting when you think about like when you studied science in school and it was just the most mundane bullshit. Like, this is actually fascinating. Experiment 3 investigates the importance of... I want to know who was funding this research. Will it tell us? Probably not. That would be interesting to know. Why are people being paid to do this? 13 undergraduates were recruited from psychology classes. Okay. A 15-inch flat panel monitor was used to present stimuli. The monitor was equipped with an infrared touch frame, which allowed participants to respond by touching the screen. The monitor and touch frame... Oh, that would have been funny if they made him like peck at like a key. The monitor and touch frame were both interfaced. Okay. The response locations were defined on the monitor, left, center, and right. Okay. Upon arrival, participants were told they were participating in an experiment on choice. It showed how to use the touch screen monitor. Participants were told this is an experiment on choice. You will have the opportunity to earn 1 point per trial by choosing among locations that appear on the touchscreen. On each trial, you will first choose among 3 white squares, then from among 2 green squares. The computer will provide feedback. You should try to earn as many points as possible. They were not told anything about Monty Hall staying or switching. Oh, that makes sense. Like, because I was like, why wouldn't they tell them the thing? But they were trying to simulate where it's like, look, you're just choosing one of 3 squares, and then just choosing from one of 2. And you get a point if you do it right. And that's it. So they're like, okay. So it's kind of like the pigeon in that sense, because they don't really know that they're supposed to be choosing something or switching or staying or anything. They're just like, I'm just trying to get more food. 200 trials in four blocks of 50. So that condition 1 and 2. Condition 1 mirrored experiment 1 and condition 2 mirrored experiment 2. So at the beginning of the first one, the computer randomly selected one of the 3 screen locations. A white square appeared. They choose one. They were darkened for a moment. Then it pseudo-randomly selected one of the 3 to deactivate. With the constraint that the deactivated location could not be the one selected as prize for the location, nor could be the one that they touched. Obviously. Okay. Green squares then appeared with the 2 remaining, and then they got a response, win or lose. The feedback remained visible for 2 seconds, and then followed a 3-second, what did they call that? It's like the interval in between. As in experiment 1, okay. As in experiment 1, switch on every trial would have produced the highest possible number of wins. And then number 2, they did the same thing where the prize location was linked to the 2 locations that had not been touched. To give the more winning strategy to be that staying rather than switching. Okay, so initially they switched more often? Interesting. And they kept switching. They didn't really change much, maybe a little bit. Participants switched on 9% more trials on day 30 than day 1. The obtained difference was not statistically distinguishable from no difference. What do they mean by obtained difference? They just mean the difference. Okay. Condition 2. They stayed more often. Why would that be the case? Oh, but the first... Wait, what? Reference lines show the probability of switching by pigeons during the first. I don't understand why. That seems weird. But it says first block. It's not the first trial. It's like the first block of 50 versus the last block of 50. That's interesting. So did they learn? Probability of switching across trial. Well, let me see what this says. Figure 6 shows the probability of switching as a function of training. The majority of learning appears to happen over the first 50 trials. In both conditions of the present experiment, participants adjusted their likelihood of switching toward the optimal strategy. Unlike pigeons, their eventual likelihood of switching fell well short of optimality. Human participants in the first block switched 20% more than pigeons, but the difference was not statistically reliable. In contrast, those human participants were 30% less likely to switch on the last block than pigeons were on the last day. That is, despite starting with approximately the same likelihood of switching, pigeons reached a point where their performance was significantly closer to optimal. In condition 2, the optimal strategy was to stay on every trial. Oh, okay. I think I was just confusing myself because I'm... Okay. Okay, I see. This how many stayed and this how many switched. It didn't really change is the point. Versus if you look at the pigeons, right? They basically look, the human ones look the same each time. The pigeons, the ones that realized switching doesn't work, switched over. Or vice versa, whatever. Yeah, switching, staying, whatever. The results of the present experiment seem to undermine the plausibility of the two alternative explanations advanced earlier. Even without the game show story, and with 200 trials of practice, humans failed to adopt the optimal strategies that the pigeons quickly mastered. Despite the lack of improvement over the last 150 trials, we do not necessarily discount the possibility that participants may have been learning in the latter stages, or that with further training they could have moved nearer. However, such a learning rate, if found, would be slower than in most other probability learning experiments, and even slower than many characteristically slow forms of learning, such as complex multidimensional category learning or implicit learning. The fact that the results of this experiment so closely match the overall patterns of previous human research on MHD would indicate that the same cognitive processes are at work in the present experiment. Apparently, pigeons' superior performance in experiments 1 and 2 is not related to the instruction set or number of trials. To what then? Oh, this is actually pretty amazing. They're like, okay, so what could be the answer? They're like, let's try another experiment. To what then might we attribute the success of the pigeons in experiments 1 and 2? So far, the pigeons' results are consistent with maximization. Specifically, pigeons learn to adopt a response strategy that maximizes the likelihood of winning on each trial, as they often do in probability learning experiments. If a maximizing strategy is indeed responsible for pigeons' performance, then one might see a different pattern of responding if there were no optimal response. That is, if neither switching nor staying resulted in a higher likelihood of reinforcement. Okay, so they got the pigeons again. The procedure was different in the way the deactivated key was determined. In experiment 4, the prize location was determined before a pigeon made its initial choice. as it was in experiment 1. However, selection of the deactivated key was not subject to the same constraints. The deactivated key could still not be the one they pecked, but it could be the key that has the prize location. Again, the critical result was whether a pigeon stayed or switched. Look at that. Holy shit, dude. It looks exactly like the human one. What? That's so weird. Taken together, these experiments show that pigeons can learn to respond optimally in a simulation of the MHD. Furthermore, they suggest that birds learn to respond optimally based on feedback received from completed trials. In particular, a bird's response strategy can be changed by adjusting the relative likelihoods of reinforcement for switching and staying. The surprising implication is that pigeons seem to solve the puzzle, arriving at the optimal solution while most humans do not. The MHD seems to be particularly tough for humans whose suboptimal choices persist in a wide variety of situations. Granberg demonstrated that the suboptimal tendency to stay in the MHD is persistent and appears cross-culturally. Brazil, China, Sweden, and US showed a reliable tendency to stay. Thus, people seem compelled to stay with their initial choice, even when it reduces expected winnings. One possible source of this suboptimality may be the heuristics that are acquired as part of a normal cognitive development. So that's normal. Denez investigated the MHD in students of varying ages. That's what I was thinking about. Finding that university students almost universally believed that staying and switching were equally likely. Younger students showed that showed a progressively weaker belief in equiprobability. Only in the youngest group that was tested, 8th graders, did even a small subset of students correctly discern that switching was the most profitable strategy. Exactly what I was saying earlier. My assumption is that if you get a child younger, they may actually figure it out. It's like the older you are, you made a choice, you're sticking to it. I don't care if it's wrong. I don't care if it gives me a reward. I'm fucking sticking to it. That's basically, Jesus is the answer. You can show me all the proof you want. I'm sticking with Jesus. That's basically the point. This finding is consistent with other investigations of suboptimal choice behaviors. For example, Langer and Imber have shown that over-practice can produce a seemingly paradoxical decrement in performance. They characterize the decrement as a negative consequence of the otherwise adaptive tendency for overlearning to free up limited attentional resources. Thus, the benefits that come with extensive education may partly be due to the acquisition of heuristics that, while efficient, can interfere with some kinds of performance, perhaps including the MHD. Extensive education. Wow. Who was it? Mark Twain said, I try not to let my schooling interfere with my education. I think it was Mark Twain said something like that. Yeah, they call it education, but it's like, what is it that they're referring to specifically? Linger. When practice makes imperfect, debilitating effects of overlearning. Hypothesized that as overlearning leads to mindlessness, the individual components of a task become relatively inaccessible to consciousness and therefore unavailable to serve as evidence of task competence. This may lead to a decrement in performance if circumstances, for example, a label connoting relative inferiority, lead one to question one's ability. Performance decrements resulted for the no practice and over practiced. Wow, I just caught that fly in between my fingers. That was weird. In a second experiment, okay, that's like a whole other can of worms, but that is interesting. Dang, this is so fascinating. Oh, interesting. Okay, that's actually pretty interesting. Let me go back a little bit. A second potentially important implication relates to the phenomenon of probability matching. When presented repeatedly with two choices, each having a particular likelihood of reinforcement, many species, including humans, tend to match the proportion of their choices to the arranged probabilities. In the MHD, the probability of reinforcement for switching is 2/3, while the probability of reinforcement for staying is 1/3. Thus, some probability matching theories might predict that responses would approximate those, 2/3 switching and 1/3 staying. This simple matching theory actually describes the performance of human participants in both conditions of experiment 3 quite well. Yeah, exactly. Pigeons, however, did something entirely different. Instead of matching, they maximized. I don't understand this probability matching. Where'd it go? When repeated with two choices, repeatedly, when presented repeatedly with two choices, each having a particular likelihood of reinforcement, many species, including humans, tend to match the proportion of their choices to the arranged probabilities. I don't understand that. It does seem to show that, though I don't understand why. That's weird. Okay. It's just based on the probabilities. But they don't actually maximize it. That's so weird. While human participants did adopt a consistent pattern of responding that was based on reinforcement probabilities, it was not even close to the optimal one. We propose that the curious difference between pigeon and human behavior described above might parallel the difference between classical and empirical probability. Classical probability is an approach to probability that is based on a complete a priori analysis of the situation. It requires no actual data collection. As when one states the probability of tossing tails on a fair coin as 1/2, or the probability of rolling boxcars at the craps table as 1 in 36. It's like a mathematical a priori, like you don't have to have any experience, which obviously the pigeons can't do. Empirical probability, on the other hand, is based on observation and estimates the probability of an event as the relative frequency with which the event has occurred in the past. The MHD can potentially be solved through either approach, right? But it takes quite a bit of thinking. A classical probability approach would involve considering every possible outcome and assigning a probability value to each, like we had to do to actually understand. An empirical approach would involve running through several MHD trials and tracking the outcomes as they accumulate. Humans seem to rely on classical probability in attempting to solve the MHD, however they do so inappropriately. reaching the conclusion that switching and staying should win equally often, because they're not doing it properly. Even trained mathematicians seem to have difficulty correctly analyzing the MHD using classical probability. Yeah, here they're talking about that stuff we read about. Pigeons, on the other hand, likely use empirical probability to solve the MHD and appear to do so quite successfully. Pigeons might not possess the cognitive framework for a classical probability-based analysis of a complicated problem like the MHD, but it is certainly not far-fetched to suppose that pigeons can accumulate empirical probabilities by observing the outcomes of numerous trials and adjusting their subsequent behavior accordingly. The MHD then seems to be a problem that is quite challenging from a classical approach, but not necessarily from an empirical approach, and the difference may give pigeons something of an advantage over humans. The aforementioned mathematician Paul Erdős demonstrates this proposition nicely. According to his biography, Erdős refused to accept colleagues' explanations for the appropriate solution to the MHD that were based on classical probability. He was eventually convinced only after seeing a simple Monte Carlo computer simulation that demonstrated beyond any doubt that switching was the superior strategy. Until he was able to approach the problem like a pigeon via empirical probability, he was unable to embrace the optimal solution. Really makes me think about the red button, blue button thing, because people have so many rational arguments as to why you should push red, but then you see blue always wins, so it's like, it's such a weird thing. Let's see these I'm gonna check these out real quick. The three prisoners problem appeared in Martin Gardner's mathematical games, mathematically equivalent to the Monty Hall. Three prisoners, A, B, and C, are in separate cells and sentenced to death. The governor has selected one of them at random to be pardoned. The warden knows which one is pardoned, but is not allowed to tell. Prisoner A begs the warden to let him know the identity of one of the two who are going to be executed. If B is to be pardoned, give me C's name. If C is to be pardoned, give me B's name. And if I'm to be pardoned, secretly flip a coin to decide whether to give me the name B or C. The warden gives B's name. Prisoner A is pleased because he believes that his probability of surviving has gone from 1/3 to 1.5. Oh, okay, I missed that. Okay. He's telling him which one's not going to be pardoned. I got it. And is now between him and C. Okay. Prisoner A secretly tells C the news, whose reasons that A's chance of being pardoned is unchanged at 1/3. B is pleased because his own chance has gone up to 2/3. Which prisoner is correct? Okay, so it's the same idea. And there's a bunch of probability. And then there's Bertrand's box paradox. A box containing 2 gold coins, a box containing 2 silver, a box containing 1 gold and 1 silver. A coin withdrawn at random from one of the 3 boxes happens to be gold. What's the probability the other coin from the same box will also be gold? It may seem intuitive that the probability of the remaining coin as gold should be 1/2, but it's actually 2/3. So you've got 2 gold, silver, silver, gold, gold. Wait, what is this? 3 equally probable outcomes. Oh, because you can't draw one from the silver one. That's why I was confused. Okay. They draw one, it has a gold one. What are the odds the other one will be gold? So is it actually 2/3? Yeah. Interesting. Because you've already drawn one, you know it's gold. You know it can't be the two silvers. Oh, but it does seem like it'd be 50-50 intuitively. I can see why. Okay, but the reason it's 2/3 is because out of the 3 scenarios where you can draw a gold coin, in only one of those scenarios is the other one silver. And in the other 2 possible scenarios, you drew it from the gold one. Interesting. Okay, it's like very similar. Boy or girl paradox. I'll have to look at that later. Wow, that was really fascinating. I mean, look at this, the references. Just like I said last night, there's just so much knowledge and information out there. Oh yeah, here it is. I read this book before. The Man Who Loved Only Numbers, the story of Paul Erdős and the Search for Mathematical Truth. That's a really interesting book about that guy's life. So much information just on choice and decisions. And man. On another note, before I end off tonight, I've been continuing my readings on Anti-Oedipus and also memoirs of my nervous illness. And this one's easier to read. About 115 pages into this one. Super interesting. Again, what's so fascinating about this in particular is him describing his, well, he doesn't call it schizophrenia, but that's what it sounds like it is. And he's so objective about it in the sense of describing it like in the third person almost. I mean, he knows it's him, but he's like so just objectively, analytically describing it, but then at the same time, he's not skeptical of it. Like, anytime something doesn't make sense or add up, he assumes it's because of a miracle. Like, for one example, he gives a layout because he had to transfer from one place temporarily to like a private asylum, and he shows like a little diagram of the house, right? And it's like mostly, like there's very few bedrooms, so it's like a small private asylum. And if I had to guess, I'd say maybe like they probably could have like 5 patients in there at one time, I would assume, at the most. And he was saying, there's one part where he's talking about going outside into the courtyard. Well, first of all, he says, well, that's a whole separate point. He said almost all the patients in the asylum, at least several dozen human beings, looked like persons who had been more or less close to me in real life. So like all the people that were the other patients and the workers and everything, he thought they were all people like from his past. Didn't think anything weird of that. And like, there's this part here. After that one walk in the garden proper, the only time I was in the open air, for 1 or 2 hours every morning and afternoon, was in the above-mentioned courtyard, or pen, as he called it. This was about 50 square yards, shut in by walls, a desolate sand pit, without bush or shrub, with nothing to sit on but 1 or 2 wooden benches of the most primitive kind. Into this pen were crammed 40 to 50 human forms at the same time as myself. Judging from their appearance, it was and is impossible for me to believe that they were really the patient population of a private asylum for the insane. In such private asylums, one finds as a rule only well-to-do patients, and only exceptionally are really demented patients or idiots to be found there. But here I saw only extraordinary figures, among them fellows in linen overalls covered in soot. Almost all of them were silent and practically motionless. Only a few used occasionally to utter certain fragmentary sounds. Among them, a gentleman I thought was in the country court was the country court counselor W, some guy, who shouted continuously for a Miss Herring. During my periods in the pen, or even inside the asylum, I never heard anything among these supposed patients even faintly resembling a sensible conversation such as carried on in private asylums among milder patients. They entered the common room one after another silently, and equally silently left it again, apparently without taking any notice of one another. At the same time, I repeatedly witnessed that some of them changed heads during their stay in the common room. That is to say, without leaving the room, and while I was observing them, they suddenly ran about with a different head. As far as I could observe, there was no relationship whatever between the size of the asylum and the number of patients whom I saw in the pen and in the common room, partly simultaneously, particularly in the former, partly consecutively. It was then and still is my conviction. That's the most interesting part about it. Is like he's like, I still believe all this. Like, I'm writing it all down and explaining it, but it still all totally happened. It was then and still is my conviction that it was impossible for all the 40 to 50 people who were crammed into the pen simultaneously with me, and who pushed towards the door of the house again every time the signal was given to return, to have found sleeping accommodation in it for the night. So logically, he's like, there's no way this many people are staying at this asylum. It's like a small, like, cottage, basically, right? It's like a little private asylum. He was just there transitioning from one place to another. I therefore thought and still think that some of them must have remained outside all the time, there to dissolve in a short time like the fleeting improvised men, which indeed they were. And he like believed all these people were fleeting improvised men, like they were just like shells, like bodies with no one inside, and they were like being animated by what he calls miracles. It's insane, dude. It's so fascinating, though. And then I was looking up earlier, like, are there any other books like this? Like, where someone wrote down all their delusions and just in a very, methodical way? Surprisingly, there's not a lot. And some of them, it was always like these, how they overcame and learned to live a life, without their schizophrenia. And I'm like, yeah, I don't really care about that part. I just want to know, like, them actually describing it. That's what's fascinating to me. But I only found a few. One of them, I ordered a few. One of them was called, like, Operators and Things. And it was about some woman who, like, traveled across the country under the control of some operators. That sounds really fascinating. And then there was another one. It's an autobiography of, I forget the guy's first name, but it's the son of Kurt Vonnegut. Like, living on, like, a hippie commune or something. And then he was schizophrenic, and apparently he just wrote it all down. Apparently it's very similar in a way to this, but a little bit more like literary, I guess. So anyways, and then I've been continuing to read this Deleuze and Guattari, Anti-Oedipus, Capitalism and Schizophrenia. And I have to say, I'm not per se suggesting anyone to read this book, because it's a doozy. But if you have an interest, you can read it. But there's other things. There's only so many books. So many books, so little time. That's what I always say. So if you have to pick and choose what to read, I'm reading this, and Freedom by Daniel Suarez. And I kind of just like, I read a little bit of this, and then I read a little bit of this, and then I read a little bit of the other one, and then I fall asleep. So that's how I do it. So I don't always read multiple books at a time, but something like this, it's like, I don't want to just read this. So that's kind of just giving you a little bit of insight into how I do it. But so it's divided into chapters, and then each chapter has multiple sections. So I don't know if chapter is the right word. They're like parts. It's like in four major parts with like basically chapters in between. And so I just finished the first part last night, which I'm assuming is probably going to be the most difficult part of the book. Just guessing. I don't know for sure, but I'm just guessing. And we talked about some of it on previous streams, but just like some of the words they use, they don't make any sense. And it's like you're reading... How can I explain it? I think I can explain it by reading the back of the book, because I think understanding the point of the book helps you understand why it's written the way it's written. It says, when it first appeared in France, Anti-Oedipus was hailed as a masterpiece by some and a work of heretical madness by others, arousing more controversy than any other work in the field of philosophy. I didn't know any of this until I found this book through reading Nick Land stuff. In it, Deleuze and Guattari set forth the following theory. Western society's innate herd instinct has allowed the government, the media, and even the principles of economics to take advantage of each person's unwillingness to be cut off from the group. What's more, those who have mental disorders may not be insane, but could be individuals in the purest sense because they are by nature isolated from society. So it's almost like they're kind of arguing that, it's kind of weird, I don't want to say it the wrong way. I'll say it one way and then I'll clarify. Like, schizophrenics actually know what's going on. But at the same time, a truly, fully schizophrenic person, the way they're treated by the system, they're a problem, right? And they're dysfunctional. But it has more to do with the fact that our system is dysfunctional than it is that the person himself is dysfunctional. But I also don't think they mean, well, I don't know, because they use, I found this book because they were referencing it, and I was like, what the hell are they talking about? That's why I got that one. And it kind of makes me think of like, the saying that a lot of people know of, like, some people, there's a fine line between being crazy, like just totally like loony, versus being just crazy enough that you actually see beyond the veil of things. You see a little bit further, you see underneath, you see what's really going on in reality. So there's like a line, because if you're not here in physical reality and you're making up all kinds of shit in your mind, that's the delusional, totally just fucked schizophrenic person. Versus a person who is saying things that are real, but because everybody's just only thinking about the system as it is, that person seems crazy, right? So it's a weird fine line. But then at the same time, all the religions that people follow, which are implicitly, at least, supported by the system we live in, like Catholicism, Christianity, Buddhism, Islam, Judaism, etc., the system doesn't try to shut them down. Like, they're always attacking them. And come on, dude. Like, there's like billions of fucking people in Christianity, billions of fucking Muslims. Like, the system ain't trying to shut them down. It like allows it. It's like a function of the system. But they are all mutually contradictory and are all created by people who, by any objective standard, are delusional schizophrenics. And if you're like, well, no, my prophet wasn't. Well, what about the other ones? Well, yeah, they are. So, okay. I mean, what's the standard exactly? St. Paul had a vision and Jesus spoke to him after he got blinded. Muhammad was choked by the angel Gabriel. So he told him to memorize the Quran. Moses, Abraham, I mean, come on. Mary was impregnated by a Holy Spirit after a visit from an angel and gave birth to a son, and she never had a human father involved. Like, come on, that's not crazy? Like, if this fucking dude said something like that, people would be like, oh, he's insane. Why? Why is that? He says crazy shit too. Batshit crazy stuff. The thing is, he never really lays out his theories. It's more like he's describing, okay, at this point, this is what was going on. This is how it was being treated. This is what was happening. And these were the things that I saw happening, and they're all delusional stuff. So he doesn't, I don't know. I haven't read the whole thing yet, but it's kind of more like he's just almost giving you a timeline of things and then throwing in his delusions into it. So he doesn't really clearly articulate it completely. So you have to kind of piece it together. But just one thing, for example, he believed that he was getting these, he calls them rays, that are attracted to his nerves. They're the nerves of God, and they're called rays, and they're attracted to his nerves. And these nerves were filling him up with a voluptuous spirit, and by voluptuous he meant feminine, to the point where his penis became inverted and he had the genitals of a woman. And then it reversed itself. And he believed that he was supposed to be like prostituted out. I mean, like crazy stuff. And when I'm reading it, he doesn't seem like he's secretly like transgender or homosexual. It was more just like a delusion he was having, and it was part of some kind of prophecy he believed or something, but then it was gone and it reversed. There was this one part I was reading last night where he was talking about, let's see if I can find it. I can't find it, but there was this one part where he was talking about these little people that were like in his head, like little devils. They literally would be inside his head, and then sometimes they would go away. He said it wouldn't have any negative effect on me; they would just go away, and then they were gone. And then it's very similar because he would be like, "This part I can't really explain it completely. I can't put it into words because I could just see something." And it reminded me of that Dan Sherman interview we watched where that guy was communicating with that alien intelligence and trying to describe that tapestry with all these different like images that he was supposed to understand and write down. And he's like, I can't really explain it very well because it's like an experience, kind of like doing DMT or some shit. Okay, anyways, so my point was just, this guy's apparently crazy, but Muhammad or Paul or Abraham are not. Why? When they're all mutually exclusive. Like, that's the thing I can't wrap my head around. It's like the Monty Hall problem. I understand the logic of it, and yet it doesn't make sense. Well, I guess not like the Monty Hall problem, because I do understand it now. But, okay. This guy is definitely crazy, right? Okay, we all agree. Everyone agrees. This guy, Daniel Paul Schraber was insane. But Paul wasn't. Unless you're Muslim, in which you're like, no, yeah, he was insane. Okay? But as a society, we accept it's okay to follow these 3 or 4 delusional people that within the context of one of the religions, the others are definitely delusional. But as a whole, as society, we can't say any of them are just flat out delusional and they're like in a cult or something following some crazy mad person. But the stuff they say has no actual real relevance to life here on Earth. It's all about the afterlife and a bunch of heaven and shit you can't see and angels and all kinds of crazy shit. I mean, just as crazy as this. And again, it's like, well, no, it's not just as crazy. It's a little bit more normal. I'm like, okay, but the Christian stuff contradicts the Muslim stuff. So from each one of their perspective, the other one is crazy. And yet it's not. So why is this guy crazy? So I think that's just kind of not that Deleuze and Guattari are saying the information this guy was saying is valid and true. They were just saying that it's like, it's sort of breaking the bounds. It's showing the cracks in the system. Anyways, that's kind of my interpretation of what they're trying to say. But anyways, after the first, let's call it chapter or section, then in section 2, which I read a little bit into that, it's called Psychoanalysis and Familialism, the Holy Family. And it was a little bit easier to read for some reason. Maybe just because they built so much groundwork, and I don't know. I just got through the first one, and then now it's starting to make a little bit more sense. But then they really start getting into like Freud and psychoanalysis and everything being tied back to the Oedipal complex. And there was this really cool point. Because they're basically making the point of like the psychoanalysts, they assumed that the unconscious was expressing itself based on certain myths, like the Oedipal myth. And he's like, these people are like, that's not at all what the unconscious is. You're applying the myths to it. And because you've been programmed with these myths, that's what you're seeing within it. But that's not really what's going on. The unconscious is way more fundamental than that. And I think that's kind of the point of what they're getting at. Because they believe then that or they observed that then psychoanalysis tries to fit everybody into the Oedipal complex and explain everything about everything going on neurotically in your life according to your relationship with your father, your mother, and the whole Oedipal triangle, basically. But there was some really cool quotes in here. But who says that dream tragedy... Actually, let me back up a little bit. And there is the essential thing. The reproduction of desire gives way to a simple representation, in the process as well as theory of the cure. The productive unconscious makes way for an unconscious that knows only how to express itself in myth, in tragedy, in dream. But who says that dream, tragedy, and myth are adequate to the formations of the unconscious, even if the work of transformation is taken into account? Grodek remained more faithful than Freud to an autoproduction of the unconscious and the coextension of man and nature. It is as if Freud had drawn back from this world of wild production and explosive desire, wanting at all costs to restore a little order there, an order made classical owing to the ancient Greek theater. For what does it mean to say that Freud discovered Oedipus in his own self-analysis? Was it in his self-analysis, or rather in his... I don't know how you pronounce this, because he's referring to Goethe. It looks like it's Goethean, but it's like Goethean? I don't know. I don't speak German, so... In his I'll just say Goethean. Classical culture. Was it in his self-analysis, or rather in his Goethean classical culture? In his self-analysis, he discovers something about which he remarks, well now, that looks like Oedipus. So it's like, is it because is Oedipus actually there in the unconscious, or is it because you're applying it to it? Like, he started exploring the unconscious, which, if you go back to like Prometheus and Atlas and a lot of the stuff we talked about with that, it's like that layer of reality that's not our normal everyday thing. It operates almost like under different rules. It's not the normal way that we think about stuff. So they were like tapping into that and exploring it a little bit. And then he's like, it was so insane that he's like, I need to put a little bit of structure to this. And at first he considers this something as a variant of the familial romance, a paranoiac recording by which desire causes precisely the familial determinations to explode. And I'll just keep going for a second. It is only little by little that he makes the familial romance, on the contrary, into a mere dependence on Oedipus, and that he neuroticizes everything in the unconscious at the same time as he Oedipalizes, and closes the familial triangle over the entire unconscious. It's actually kind of interesting. He neuroticizes everything in the unconscious. The schizo, there's the enemy. Desiring production is personalized, or rather personologized, imaginarized, structuralized. We have seen that the real difference or frontier did not lie between these terms, which are perhaps complementary. Production is reduced to mere fantasy production of expression. So like the stuff coming out of the unconscious is fantasy, it's expression, it's not something real there, is what they're getting at in terms of what Freud and the psychoanalysts are saying. It's all just fantasy. And not even an avant-garde theater such as existed in Freud's day, but the classical theater, the classical order of representation. The psychoanalyst becomes a director for a private theater, rather than the engineer or mechanic who sets up units of production and grapples with collective agents of production and anti-production. Psychoanalysis is like the Russian Revolution. We don't know when it started going bad. It's actually, again, it's one of those things where you might be reading it and kind of like struggling to understand, but then you go back and you're like, okay, no, it's actually pretty good stuff. The only reason why it's difficult reading it out loud is because I know some of these words probably don't make sense out of context. Like this sentence. Let's see. The desiring machines are always there, but they no longer function except behind the consulting room walls. Behind the walls or in the wings, I was just reading this other part. Okay, sorry. Behind the walls or in the wings, such is the place the primal fantasy concedes to desiring machines, when it reduces everything to the Oedipal scene. They continue nevertheless to make a hellish racket. Even the psychoanalyst can't ignore them. He tends therefore to maintain an attitude of denial. All of that is surely true, but it is still daddy-mommy. Over the consulting room door is written, "Leave your desiring machines at the door. Give up your orphans and celibate machines, your tape recorder and your little bike. Enter and allow yourself to be Oedipalized." I'm going to read this one little section too, because that was pretty good. What came to pass in the history of psychoanalysis? Freud held to his atheism in heroic fashion, but all around him more and more they respectfully allowed him to speak. They let the old man speak, ready to prepare behind his back the reconciliation of the churches and psychoanalysis, the moment when the church would train its own psychoanalysts, and when it would become possible to write in the history of the movement, "So even we are still pious." Let us recall Marx's great declaration. He who denies God does only a secondary thing. For he denies God in order to posit the existence of man, to put man in God's place, the transformation taken into account. But the person who knows that the place of man is entirely elsewhere does not even allow the possibility of a question to subsist concerning an alien being, a being placed above man and nature. He no longer needs the mediation of myth. He no longer needs to go by way of this mediation, the negation of the existence of God, since he has attained those regions of autoproduction of the unconscious, where the unconscious is no less atheist than orphan, immediately atheist, immediately orphan. Yeah. I'm assuming probably a lot of that doesn't make sense as I read it out loud, but in context, it's really, really interesting. So yeah, I'll continue reading that one. I'm reading, like I said, Freedom by Daniel Suarez, and that book is, well, the first book, Damon, and then Freedom. It's actually kind of surprising. I don't really want to say too much because it'll spoil it in terms of why, but I can kind of see maybe where it's going, and it's. I really was not expecting it to be that complex and like, kind of like forward thinking about things. Because even though it has the feeling of like you're reading like a thriller or something, there's a lot of really cool ideas in that book. So I would definitely recommend reading those. I haven't finished Freedom, but it's already really good. I'm probably like, I don't know, a sixth of the way through it. But that one's pretty good too. What else? I guess that's it for tonight, guys. And I don't know what we'll talk about tomorrow, but I'm sure we'll find something interesting. That paper about the pigeons was super fascinating. Might be fun to go through and look at a lot of the psychological research. There's probably so much. But okay, well, I'll leave it at that for tonight, guys, and I will see y'all tomorrow. Bye.